Hello everyone, my name is Lakshman. I am pursuing my degree in the CSC department of the SBC College, Bangalore. Today, I am here to explain a PowerPoint presentation on the pointer estimation and interval estimation concept in calculus and joint distribution. In this slide, let us see the contents that we are going to see in this presentation. The first one is what is joint distribution. Second one is what is point estimation. Third, what is interval estimation? Then we are going to see some problem examples based on the two concepts. Now, let us come to the introduction. Given two random variables that are defined on the same probability space, the joint probability distribution is the corresponding probability distribution on all possible pairs of outputs. The joint distribution can just as well be considered for any given number of random variables. The joint distribution encodes the marginal distributions, that is, the distributions of each of the individual random variables. It also encodes the conditional probability distributions, which deal with how the output of one random variable is distributed when given information of the output is also a random variable. Now, in this slide, let us come to the main topic of point and interval estimation. To estimate an unknown parameter of the population, concept of theory of estimation is used. There are two types of estimation, namely point estimation and interval estimation. The first one, point estimation. When a single value is used as an estimate, the estimate is called as the point estimate of the population parameter. In statistics, a parameter is a characteristic of a population which the researcher or statistician wants to assess. Examples of parameters include the population mean, the population variance, and the population proportion. Scientists use these characteristics to find sample statistics, which include the sample mean, variance, and proportion. They use point estimators when finding a single value estimate of a parameter. For example, finding the mean of a sample is a single value that represents a population mean. Now let us come to the example. 55 is the mean mark obtained by a sample of 5 students, randomly drawn from a class of 100 students. Considered to be the mean marks of the entire class is 45. The single value 55 is the point estimation in this example. Now, let us come to the next topic, interval estimation. Generally, there are situations where point estimation is not desirable and we are interested in finding limits within which the parameter would be expected to lie is called an interval estimation. Researchers use this type of estimator to calculate a range of possible values for a given parameter and determine the likelihood of each being true. They assess the level of possibility for each value in the estimate range by calculating its confidence interval. A confidence interval represents the likelihood of a finding being true. Calculating this function allows scientists to determine the chance that each value in a range of possible values representing the parameter is likely to be accurate. For example, a researcher might use an interval estimator to calculate the reliability of data collected in the survey. A survey of collection of the online retailer shows that 75% of respondents plan to purchase from the company again. The researchers conduct the study to obtain the data about how many customers make repeat purchases from the company. Now, let us come to the concept of confidence interval used in point and interval estimation. After obtaining the value of the static t sample from a given sample, can we make some reasonable probability statements about the unknown population parameter theta? This question is very well answered by the technique of confidence interval. Let us choose a small value of a, which is known as a level of significance, which is 1% or 5%, and determine two constants, say C1 and C2, such that PC1 is less than the constant and it is less than C2 slash mod T is equal to 1 minus alpha. The quantities C1 and C2 so determined are known as the confidence limits, and the interval is C1, C2, within which the unknown value of a population parameter is expected to lie is known as confidence interval. 1 minus A is called a confidence coefficient. Confidence interval for the population mean for large samples when is known. If we take repeated independent random samples of size n from a population with an unknown mean but unknown standard deviation, then the probability that the true population mean mu will fall in the following intervals is 1 minus alpha, that is p is equal to, as we can see the equation, is equal to 1 minus alpha. So the confidence interval for population mean mu when standard deviation sigma is known and is given by x bar plus or minus z subscript alpha by 2 into sigma by root of n, where alpha is equal to confidence level, sigma is equal to standard deviation, n is the sample size, x bar is the sample mean, and z subscript alpha by 2 is the confidence coefficient. These are the variables used in the below equation. Now, in this slide, let us solve one problem example based on the concept of point estimation and interval estimation. A machine produces a component of a product with a standard deviation of 1.6 cm in length. A random sample of 64 components was selected from the output, and this sample has a mean length of 90 centimeters. The customer will reject the part if it is either less than 88 cm or more than 92 cm. Thus, the 95% confidence interval for the true mean length of all the components produced ensures acceptance by the customer. The solution: here mu is the mean length of the components in the population. The formula for the confidence interval is mentioned below. X bar minus z subscript alpha by 2 into sigma by root of n is less than mu, and it is less than x bar plus z subscript alpha by 2 into sigma by root of n. Here sigma is the standard deviation and its value is 1.6 centimeter, comma z of alpha by 2 is the constant value in all the problems and it is equal to 1.96, and x bar is equal to 90 and number of components is n is equal to 64. Then SC is equal to sigma by root of n, where 1.6 by root of 64 is 0.2. This implies that the probability that the true value of the population mean length of the components will fall in this interval 89.61, 90.39 at 95%. Hence, we concluded that 95% confidence interval ensures acceptance of the component by the customer. Now, since we have seen the concept of point estimation and interval estimation and some problem examples based on it, let us see some applications where this concept is used. Since point and interval estimators measure different values, they have different applications. Typically, researchers use point estimators to find sample means. This is a single value that they use to generalize to the total population. Researchers use interval estimators to assess the accuracy or credibility of different values in a range. We have reached the end of the presentation, guys. Hope you liked my presentation on the concept of point estimation and interval estimation in joint distribution concept, and let us meet in the next presentation. Thank you.